there are two questions. The total flux through the sphere. For that situation, we have to try to find out the total flux through the sphere. Okay. For these two figures, we have to find out the total flux through the sphere. Okay. The first question says that a linear charge density lambda. This is the infinite linear charge density is the lambda. Okay. And this linear charge density is kept at a distance x from this side, and radius is given. Radius equals to the r. Radius of this solid sphere equals to the r. Okay. We have to find total flux through the cube. Through the sphere. We know that the total flux through the sphere, which will be equal to surface integral E dot dA or Q enclosed upon epsilon naught. Okay. So we have to find out the Q enclosed upon epsilon naught. Q enclosed surface integral means we have to find out the enclosed charge by the surface. Important चीज. ये इलेक्ट्रिकल फ्लक्स निकालने के लिए फाई इक्वल टू सरफेस इंटीग्रल ई डॉट डी अप्लाई कर सकते हैं जब ई नॉन यूनिफॉर्म हो. जब ये लिखेंगे क्यू इनक्लोज अपन एप्सिलॉन नॉट, देन हम लोग क्या करेंगे, गॉसियन सरफेस हम लोग बोलते हैं इसको. इलेक्ट्रिकल फ्लक्स क्यू इनक्लोज अपन एप्सिलॉन नॉट क्या हो, गॉसियन सरफेस है. फ्लक्स दो तरीके से इसमें निकाल सकते हैं, ई डॉट डी ए से और इससे. ये गॉसियन सरफेस होगा. मतलब जो क्यू इनक्लोज है, इनक्लोज क्या होगा, हमारा जो 3D सरफेस का होगा, और 3D सरफेस वो भी क्लोज सरफेस होगा. क्लोज सरफेस के द्वारा जो इनक्लोज्ड इलेक्ट्रिकल फ्लक्स होगा कि जो कैलकुलेट करेंगे वही उसके कॉरस्पॉन्डिंग उस क्लोज सरफेस के द्वारा 3D सरफेस के द्वारा वही जितना अंदर जो चार्ज होगा वही हमारा क्या होगा, क्यू इनक्लोज्ड होगा. यहाँ पे 3D सरफेस क्या है, ये है, लेट अस सपोज गॉसियन सरफेस है. दिस इज द स्फीयर. सो वी हैव टू नीड द इलेक्ट्रिकल फ्लक्स थ्रू द स्फीयर. हाउ वी कैन कैलकुलेट इट? The electrical flux phi equal to Q enclosed upon epsilon naught. Q enclosed. This is the linear charge density lambda. We know that linear charge density lambda equals to the linear charge density equals to the charge upon length. Okay, charge upon length. But this is a 3D surface. Sphere. So only we have to need the charge for that point. This is the Q enclosed charge, or we can say this is the Q enclosed charge. Okay. The given distance equal to x, given distance, and radius equals to r. So trying to find the geometry. Let us suppose this is the r of r due to radius. This is the 90. Okay. So this value. Let us suppose O point, A point, B point, and C point. So AC equals to the value of AC, R radius x, this value equal to the root of R square minus x square. So this value is also equal to root of R square minus x square. Add equal to 2 times of that number. So this radius, whole radius, which will be equals to the 2 times of R square minus x square. So Q enclosed Q divided by length. For this length, we have to find out the charge Q. This is the formula of linear charge density. Charge upon length. Okay. So this charge is distributed on length, and length equal to 2 times of r square minus x square. X given, r given, lambda is the linear charge density. Then empirically we can say Q equals to the lambda into L. This is the linear charge density. This is the charge Q enclosed by the that surface. Only this charge enclosed now. Okay. So Q enclosed equal to the lambda into L. L 2 times of root of r square minus x square divided by epsilon naught. This is the electrical flux through the sphere. Electrical flux through the sphere. Lambda into 2 into root of r square minus x square divided by epsilon. Okay. This question will be completed, and we are coming the question number 2. Question number 2 says that this is the ring and this is the sphere. In the question, given condition is the center of the ring, which is the circumference of the ring, passing through circumference of the ring. Also the center of the sphere C2, this is the passing through the circumference of the ring. Okay, for these situations, the charge on the ring which will be equal to the Q. We have to need the electrical flux through the sphere, through the that sphere. So required charge for that, only required charge for that. So only required charge for that. So this is the required charge. This is the 3D surface now. Sphere is the 3D surface. So net enclosed charge equals to the that number. Enclosed charge. We have to require number. Required charge. Total flux through the sphere, which will be equal to Q enclosed upon epsilon naught. Q enclosed. We are trying to find out the Q enclosed. Okay. Look here. This is the C1. This is the C2. Center of that circumference passing through C1 and C2. That figure is not correct here. We suppose that figure. Okay. You can understand. This is the 90. Understand this value equal to 90. Okay. Figure is not correct. This value equal to 90. Symmetrical. So this value equal to the 90. And that is the radius. Also that is the radius. Okay. That is the radius. So this value is also the radius. Because this is the ring now. So center and circumference. This is the radius R. But this is the 90 degree. So this is the bisector of R. This is the bisector. So that value equal to the R by 2. Okay. If this angle equal to the theta, then cos theta equal to base upon hypotenuse. Base is the R by 2 and hypotenuse is the R. So cos theta equal to 1 by 2. 1 by 2 equal to the cos 60. So this value equal to 60 degree. 60 degree. Also this value equal to 60 degree. This value equal to 60 degree. Okay. Also you can say this value equal to 60 degree or this value equal to 60 degree. Okay. So whole value equal to the 120 degree. This whole value equal to the 120 degree. R by 2. Why you can say R by 2? This is the bisector of R. So R by 2. Angle theta, cos theta equal to base upon hypotenuse equal to the 120. So you can say this is the 120 degree. So 120 degree is this part of a ring. Okay. So 120 plus 120 plus 120 equal to 360. In parallel, the charge Q distributed on 360. You can say the charge Q is distributed on 360. The 360 degree charge is distributed for Q. 1 degree is the Q divided by 360 degree. And we have to need the 120 degree. Charge for the 120 degree. Charge for the 120 degree. This is the 120 degree. Total charge will be on the 360 degree. So charge on the 120 degree. And that way we can say Q divided by 360 into 120 equal to the Q by 3. So this is the required charge which will be equal to Q by 3. That is the important thing. Okay? Q by 3. So that value which will be equal to the Q by 3. Q by 3 divided by epsilon. This is the total flux through the sphere. Total flux through the sphere. Okay.